All right, last semester we stopped with polynomials. Again, this is kind of what polynomials look like. It's just an algebraic expression where you have variables and exponents. So far with polynomials, we have added and subtracted, which is combining like terms. We have multiplied either using FOIL or the box method. And we have divided using long or synthetic division. And then we also factored. I taught you four methods for factoring. We've done the star. We've done factor by grouping. Perfect squares. And perfect cubes. Today we're going to continue with polynomials. These next 2 units are going to be about polynomials as well, but we're going to be solving polynomials this unit. So with this unit, remember we've solved quadratics before. Zeros, roots, and x-intercepts all mean the same thing as solutions. So no matter if I ask you what are the x-intercepts of the polynomial or what are the zeros of the polynomial, you're just going to solve the polynomial. So the way that we're going to solve polynomials today is we're going to find their x-intercepts by factoring. We're only going to use 3 of the 4 methods I taught you before. We're not going to do perfect cubes. And factor by grouping only shows up like twice on your homework. So really we're going to mainly be hitting the star method today. Before we get into solving, I do have to explain the fundamental theorem of algebra. If you look it up, it's actually this really weird, wordy, really long theorem. In short, all it really means is the number of solutions or x-intercepts a polynomial has is the number of the degree, so the highest exponent. So if I'm looking at a polynomial that starts off with 5x to the 7th, that tells me that there are 7 solutions to that polynomial. So that's kind of a good check just to make sure that you found all of the solutions that polynomial has. What you're going to notice is sometimes when you solve, you're going to get the same answer a couple times. So you might get like x equals 1. Once you factor it down to here, if you solve both of these factors, you're going to get x equals 1 twice. So if the same solution shows up more than once, that's your multiplicity. So your answer would just be x equals 1 with a multiplicity of 2. And that'll make more sense once you see that in an example. So for our first example, I'm just going to show you, I want to solve the following polynomial. And I just put a graph over here so that we could see the x-intercepts. You're not going to have to graph in your homework. So when I factor, there's 3 terms, which tells me I'm going to do the star method. But any time before you factor, you always have to look for the GCF. I see that x cubed, 4x squared, and negative 12x, they all have an x in common. Another thing you have to be sure of before you factor is it has to be set equal to 0. Since this one already equals 0, I don't have to do anything here. So once I take an x out of everything, I can now factor this using the star method. So a times c goes at top, so it's negative 12. B goes at the bottom, and A on either side. So if I'm trying to think of 2 numbers that multiply to negative 12 but add to positive 4, that's going to be 6 and negative 2. 1 over 6 does not simplify, and 1 over negative 2 does not simplify. So I'm going to bring down my GCF and then write my 2 factors. So this is x plus 6 and 1x minus 2. If you can think back to the quadratic unit when we were solving quadratics, I took every single factor and every single variable and I set them equal to 0. X minus 0, or x equals 0, there's nothing to do there, so I'm just going to bring it down. For this one, to get x by itself, I subtract 6 on both sides to get x equals negative 6. And on this last one, I have to add 2 to get an answer of x equals 2. I started with a degree 3 polynomial. I have 3 solutions. And so there, I'm done. That's all you're gonna have to do for the homework. Later, next month, you're going to have to start graphing polynomials. So just to show you, these solutions are all their x-intercepts. So I have an x-intercept at 0, an x-intercept at -6, and an x-intercept at 2. So when we start graphing, we would know that this polynomial would look something like that. So here's a couple more examples. Over here on example 2, we notice that it's not set equal to 0. Since my degree, since the leading coefficient of that is positive on this x squared, I'm going to take x and 56 and I'm going to move it to the same side as x squared. So I'm going to be left with 0 on the right side and have x squared minus x minus 56. So it's set equal to 0. Again, there's 3 terms, so I'm going to use the star method. X squared, negative x, and negative 56 have nothing in common, so there's no GCF. So I just need to start with filling in the star. So negative 56 is on top, negative 1 on bottom, and 1 on the sides. My 2 numbers that multiply to negative 56 but add to negative 1 is negative 8 and 7. Again, they won't simplify. So I have 1x minus 8 and 1x plus 7. So I set both factors equal to 0. So my answers here will be x equals 8 and x equals negative 7. I started with a degree 2 polynomial, and I have 2 answers. Example 3 is a little different. There's still 3 terms, but again, it's not set equal to 0. I look for the highest exponent, that's 4 on this side. And since this is already a positive, I'm going to take 6x to the third. I'm going to move it over here. Since none of these terms have the same exponent, I can't combine anything, so I just write them all in a row. Again, look for a GCF. 2x to the fourth plus 6x to the third minus 108x squared. They all have at least 2 x's, so I can take out an x squared. And 2, 6, and 108 can all be divided by 2. So this is going to leave me with x squared plus 3x minus 54. So again, I have 3 terms, so I am just going to use the star method. Since I took out a 2x squared, that's just going to stay out here. And I'm just going to deal with a is 1, b is 3, and c is negative 54. So a times c is negative 54, b is 3, and 1 on the sides. My 2 numbers that will multiply to negative 54 but add to 3 is 9 and negative 6. Again, 1 over 9 won't simplify, and 1 over negative 6 won't simplify. So my factors are x plus 9 and x minus 6. Now here again, I'm going to set every single variable equal to 0 and solve. So if I start over here, I add 6 to both sides to get x equals 6. I subtract 9 from both sides to get x equals negative 9. This 2x squared we haven't seen before. The first thing you get rid of is that multiply by 2, so I divide by 2. So I'm left with x squared equals 0. And if you remember, the inverse of squared is a square root. So those will cancel. And I have to remember, when I take this square root, my answer is going to be positive and negative. So So I'm going to have x equals positive and negative 0, but that doesn't make sense. So that means positive and negative 0 is just 0. So my answer of 0 shows up twice. So this is where our first multiplicity comes in. Since it's x squared equals 0, that means my answer of 0 shows up twice. So I have the answers of x equals 0. So I have 4 answers, and I started with a degree 4 polynomial. So those are all of your examples using the star method. I have one last example for factor by grouping. I know this is factor by grouping because there's 4 terms. So if you remember, or if you don't remember, pull out your notes from last unit or last semester. When I have factor by grouping, I first look for a GCF for all 4 terms, and I don't see one. So I'm going to split this polynomial in half. So step 1 is take the GCF out of the front half. So I have x cubed plus 3x squared. They have 2 x's in common, so that's just x plus 3. Negative 4x and negative 12. Since this 4 is negative, I know I'm going to pull out a negative, and 4 and 12 both have 4 in common. So that again leaves me with x plus 3. Remember, these 2 parentheses should always match. So I'm going to go ahead and write x plus 3 down here. My other factor comes from the 2 pieces that I am multiplying to x plus 3. I'm multiplying an x squared and a negative 4. And of course, if you recognize here, x squared and negative 4 are both perfect squares. So this will break down to x plus 2, x minus 2. So I have 3 factors, and I set each of them equal to 0. And when I solve each of these, this will give me x equals negative 2, x equals positive 2, and x equals negative 3. I have 3 answers, and I started with the 3rd degree polynomial.